Make sure you've got 11.2 and 11.3 pretty well figured out because you're going to have a quiz on both of those. 11.2 is due tomorrow, and 11.3 won't be due until Wednesday. Okay? Everybody clear there? All right. So let's go. Oh, very generous. Very, wow. Just heaping the accolades on me. So we talked about, again, just emphasizing, because this is going to come up on a test, and when you throw all these together, you've got to know which one you're working with, what form it needs to be put in, and all that sort of stuff. And if you make a mistake and say you're dealing with an ellipse when you're actually dealing with a hyperbola, you're going to get the whole thing wrong. Okay, so make sure you know this. If it's got one squared variable, it's got to be a parabola. What if y is squared? Which direction could it open? Left and right. Okay, if x is squared, then it's going to open up or down. Okay, if you've got two squared variables, then you have to look really closely. If they have the same sign and the same coefficient, it's got to be a circle. And again, we're talking about once you put everything on one side. Okay, if they have the same sign and different coefficients, then it's going to be an ellipse. And if they have just different signs, doesn't matter what the coefficients are, even if they are the same, if they've got different signs, then it's going to be a hyperbola. We talked about the definition, and we kind of sketched why it made that type of shape on the board. Talked about the foci, and then we had a problem like this, just a regular old one that hasn't been moved anywhere. We made the point that its its center is at the origin. The major axis is determined by whichever one's bigger. So the bigger number is underneath the x. That means it's going to be longer in the x direction than it is in the y direction. Okay. Let's see. The foci are always on the major axis. So here's the major axis running right here. The foci are always on there. They are never on the minor axis. They're never on the smaller one. And when we drew those on the board, you could see what happened when we moved the foci closer together and further apart and that sort of thing. Okay. And then there was this little formula that helps us figure out how far the foci are from the center, and it's a squared minus b squared equals c squared. It's like the Pythagorean theorem, but it's a minus rather than a plus. Can anybody remind us why it's got to be a minus rather than a plus? Yes? It has to be inside. Very good. Okay, so this is going to tell us how far we go in the x direction. We're going to go 5. Well, we've got to go something less than 5 to go from the center to the foci. So we do that by taking 25 and subtracting the smaller one. Okay, big one minus the small one equals c squared. Okay, we graphed a couple of these. We looked at semi-major axis, semi-minor, all that sort of stuff, and then we graphed these guys right here. Any questions? Okay, let's do the last couple problems on the notes. Then we'll take a look at a few in the assignment, and then I'll give you the rest of the time to work. Okay. So we looked at example number 3, and it said find the vertices, foci of each ellipse, then graph the equation. So here's what we did. We looked at this. This was not in a nice graph-friendly form. Okay, so we made it in a graph-friendly form. Now I'll be the first to admit that's pretty darn ugly right there. Okay, so this is going to be about the worst one we've dealt with so far. So let me blow this up so we can see what we've got here. First of all, what's the center? Where's the center? 0, 0. Okay, so the center's at the origin, so we're right there. How far do we go in the y direction? Square root of 2. Whatever the number is underneath the y, we take the square root of that. So that's going to be radical 2. So I'm going to go up. Radical 2 is in between 1 and 2. It's about 1.4. So I'm going to go up 1.4 and down 1.4. I'm going to go to the right and to the left. So underneath the x is an 8. Square root of 8 is, okay, we could write it as 2 radical 2, and this one was just radical 2. Okay, it's a little less than 3. So if I'm going to sketch that, it's about right here and about right here. Okay, and then I said I like to just draw a quick little box. It helps me get the right shape here when I'm graphing this. So this is going to go around here to here and around like this. Okay, now I'm going to go ahead and label every one of the vertices. So I'm going to label these 4 points right here where the ellipse touches this box. So this is going to be, I went to the right, radical 2 radical 2, so this is going to be 2 radical 2 comma 0. What about this one over here on the left? Negative 2 radical 2 comma 0. Okay, didn't go up or down. On this one, the x-coordinate is going to be 0, and I went up radical 2, and here I went down radical 2. Okay. Now, if I did this on a test, if I went from this equation, put it in this nice graph-friendly form, figured out that this is what it looked like, would that give me all of the points? Not all of them. It would be close, but not all of them, because we've got to find where the foci are. So, again, to find the foci, I'm going to take which one? The big one, 8, and I'm going to subtract the small one, 2, and that's going to be c squared. So c squared is going to be 6, so that means c is radical 6. Now, do you know exactly what radical 6 is without a calculator? I don't. Okay, could we take a guess as to what it is? Somewhere between perfect square of 2 is 4, perfect square of 3 is 9. This is 6. It's got to be somewhere in between 2 and 3. A little closer to 2. A little closer to 2. All right? Now, somebody throw that in the calculator. What is it? Radical 6. It's Charles's job. 2.44. Okay, now all you have to do is get it somewhere in the right ballpark. 2.44. So I'd say about right there and about right there. Now, if this were one on the test and you were given this graph, I wouldn't try and stuff those inside there. I'd just draw a line and I'd say there's a focus here and there's a focus there, and then I'd label those points. So would you go ahead and label those, please? They're not quite as awful as they seem. I'm at 0, 0, and I go forward radical 6, so that's going to change the x coordinates. So this is just radical 6 comma 0, and this one is negative radical 6 comma 0. Look at all the kind of conjugates we've got floating around there. Okay. All we did is, I mean, lots and lots of symmetry there. Okay, any questions? Everybody got that one? Ready to move on? Okay, let's take a look at this guy right here. What's wrong with this one? Not in a graph-friendly form. Okay, that graph-friendly form looks something like this. It's x minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. We've got to have a 1 over here, perfect square with y and a perfect square with x. Now everybody watch, please. Does it matter whether the x or y comes first? No. It doesn't. Okay. Now I put this as a squared underneath the x. It doesn't matter. Again, it's whether a is underneath the x or a is underneath the y doesn't make any difference. As long as you're thinking a is always the big one. Okay? Now the other caution I'd give you is, remember, h is always with x, k is always with y. Okay? It's not always the case that a is with x and b is with y. Okay? So make sure you keep that straight. Again, if you want to look in the book and memorize all 4 of the different forms that they had for these, be my guest. Much easier to think. H goes with X, K goes with Y. A is the big one, B is the small one. Okay? Any questions? Okay, so let's get this in the right form. So the first thing I'm going to do is I'm going to collect the x's together. So this is going to be 4x squared minus 8x. This is going to be plus 3y squared minus 6y equals 5. So we've got to make a perfect square. We've got to complete the square. So I save room for that. Yes? It is. Thank you. Monday I was seeing if you're on your toes. Clearly you are. Okay. If we're going to complete the square, can we do that with a 4 in front of the x squared? No. We can't. So the next thing we do is we factor that out. Now, if you can do these 2 steps in one, that's totally fine with me. This is going to be a 4 and x squared plus 2x. I'm going to close the parentheses there. Then what am I going to take out of here? A positive 3. So we want to write the positive 3. I've got a y squared minus a 2y. Close the parentheses, and over here I have a 5. So everything that I've written on here, all I'm doing is just rearranging. All of that was in the problem to begin with. Now we're going to start changing it. Any questions? Half the middle coefficient is positive 1. I square that, I get 1. Now, when we did this with parabolas several months ago, and if you were in my 1010 class, I said when you put a number in here to put it in a nice graph-friendly form, when you complete the square inside the parentheses, what I like you to do is to draw a line from that number outside right to that number right there. That reminds us that we have to distribute the 4 into the parentheses. 4 times x squared is 4x squared. That was there to begin with. 4 times 2x is 8x. That was there to begin with. What's 4 times 1? Positive 4. That was not there to begin with. I have the luxury of compensating on the other side. So if I really added 4 to this side, what do I do over here? I add 4 over here. Okay? You add 4. If we were compensating on the same side, we'd have to cancel out on the same side, so we'd do the opposite. We're just doing the same thing to both sides. Got that? Okay, let's take a look at this one right here. Half the middle coefficient is negative 1. I square that, I get positive 1. When I write that number, I draw this little line. What I've really done here is added 3. To compensate on the other side, I add 3. Are there any questions? Sure? Okay, then here's what we've got at this point. I have a perfect square with x, which is 4x plus 1 quantity squared. I have a perfect square with y, so I've got 3y minus 1 quantity squared. And then over on the other side, let's see, I put all those numbers together and I get 12. Any questions? Is this in graph-friendly form, Alex?
Yes. No.
What's wrong with it? Right, it has to be divided by a and b. We need numbers down here, okay, and we need this number right here to be a 1. So how do we turn that 1 into that 12 into a 1? Divide by 12. So we're going to divide both sides by 12. Okay, before you do that, I want you to look. Notice that in front of the x is a 4, in front of the y is a 3. They have the same signs but different coefficients. This still is an ellipse, you can tell in this form. We're going to go ahead and divide by 12. And here's what I've got. I've got, let's see, x plus 1 quantity squared over 3 plus y minus 1 quantity squared over 4 equals 1. Now, I take a good look at that, and I need to figure a few things out. Where is the center? Don't say anything out loud. Think about it for a second, and be careful, because remember I said somebody's going to screw this up. Make a silly mistake like this on the test. Please don't let it be you. Find the x. What's with the x? A 1, so we're going to make that a negative 1. And with the y? Positive 1. Okay, there's the center. Again, it's much more difficult if the y comes first. Okay, it doesn't make any difference if it comes first or second. The h is with the x, the y is with the k. So this is at negative 1, 1. So that means my center is right here. And then how far am I going to go in the x direction? Square root of 3. Okay, square root of 3. So in the x direction, I'm going to go to the square root of 3. That's a little less than 2. So I'm going to go about right there and about right there. Now, if this point is negative 1, 1, if this point is negative 1, 1, and I moved over here radical 7, this would have the same y coordinate. So would this one. But the x coordinate, I would have added radical 7. So this would be negative 1 plus radical 7. What would this one be? Negative 1 minus radical 7. Whoops. Yeah.
Where did you get radical 7?
Oh, sorry, radical 3. Monday for me too. Okay. Good there? Okay, how far do we go in the y direction? 2. We go 2 in the y direction. So that's just up 2 right here, down 2 right here. Doesn't look much like a ellipse. Okay, I'm going to draw the little box around here just to help out. And here's our ellipse. It's a little longer in the vertical direction than it is in the horizontal direction, but not much. Looks a heck of a lot like a circle. Okay, now when we did this last week on the board, what happened? I mean, how did we get it to look more like a circle? What did we do the foci? Move them closer together. So we're expecting to find foci that are fairly close together. All right, let's see what we get. How do we figure out where the foci are? Okay, a minus b, a squared minus b squared, or the big one, subtract the small one. The big one is 4, so we do 4 minus 3, that's c squared, so that's 1 equals c squared, so c equals 1. Okay, the foci are always on which axis, the major or the minor? Major. So the major axis is running vertically, so that means I'm up here, there's a focus, and right there, there's a focus. So again, let's label those points from outside. This would be up 1, so this is going to be -1, comma 2. This is going to be -1, comma 0. Didn't go right or left. That's where the two foci are. Now, if I did all this work on a test and labeled that, would I get all the points? I should label 2 other points. I should label this point up here, and I should label this point down here. If I'm at -1, 1, and I go up 2, that would put me at -1, comma 3, and this would be -1, comma -1. Okay, any questions there? Easy enough? Okay, once you get the hang of these, they're really not too bad. Okay, let's take a look. We've got 4 more, and then we'll look at some from your assignment. It says, find the equation of the ellipse given the following information. Now, it doesn't say graph, it just says come up with the equation. So I've given you some graph paper there just so you can chart this out. It's a lot easier if we just plot the information. Center's at 0, 0. It's got a focus at 0, 2. So 0, 2 up here. So there's the center, and I like to label these. So the center is here, the focus is here, and then it has vertices at 0 plus or minus 3. So it's got a vertex here, and it's got a vertex here. Those 3 pieces of information, and we need to figure out, gosh, what equation is this? Well, I want you to think for a second. So usually people get this stuff. That's not hard to do. They start asking questions when it describes an ellipse, and you have to come up with the equation. So there's plenty of information here to figure it out. What does this tell us right here, that the center is at 0, 0? Yeah, x squared and y squared. So if you want, just write this down. X squared over something plus y squared over something equals 1. I mean, everybody can write that down. If its center is at 0, 0, we ought to be able to write that down. Now, the nice thing about the way I've taught you to do it is it doesn't matter whether the x comes first or the y comes first. We're going to look at this and we're going to figure out, well, gosh, what should go underneath the y squared and what should go underneath the x squared. Doesn't matter whether they're first or second. Okay? So, let's figure this out. We've got information going this direction. What direction is this again? Vertical direction, in the y direction. We ought to be able to figure out what goes underneath the y. Okay, this is going backwards from what we've normally done. Emily, what do you think?
This just came to my mind, and it has to, the focus is 2, so it means it has to equal 4a squared minus b squared, it has to equal 4, right?
You are correct. A squared minus b squared. The big one minus the small one has to equal c squared. And c in this case is 2, so this would be 2 squared, this would be 4. Okay, a squared minus b squared has got to be 4. Okay, that's true. Okay, what else can you tell? If this distance right here is c, what's this distance right here? Is it a or b? Okay, how many say a? How many say b? Okay. Which axis is this? Is this the major or the minor axis, and how can you tell? This is the major axis. Why? Because the foci are on there. Okay? That's got to be the major axis, so this has to be the big one. So if that's 3, that's what A is. So what's A squared, and where do you put it? What's A squared? 9. Where do you put it? Under the Y. So we're going to put a 9 underneath the Y. Everybody good there? Okay, there's not really any math work to do here. We figured all this out just knowing what the general form is, the nice graph-friendly form of an ellipse, and we're just thinking. From the center to a vertex is 3 units. That's in the Y direction. Square 3, that's 9. It's got to go underneath the Y. So we filled all this in without even thinking or without doing any math, just thinking. Okay? Now, how do you figure out what B is, Emily?
Well, it's 5 because 4.
Very good. We know what A squared is. That's 9. Minus B squared is 4. So if I solve this, I'm going to switch places here. This would be 9 minus 4 equals B squared. So this is going to be 5 equals B squared. Now the cool part about this is it didn't say graph it, did it? So do you need to know what B is? It happens to be the square root of 5, so we could kind of sketch it out. It would look something like that. That's really ugly. Okay? But all we need is B squared, so we'd put a 5 right here. We are done with that problem. That is the equation. The graph just helps us think our way through it. Okay? Tiny bit of math on that problem and we're all set to go. Let's take a look at the next one. Are there any questions before we move on? Okay, let's look at the next one. Center is at 2, -1. Stop right there. You should be able to write something down. 2, -1 is the center. Write down what that tells you. If this were a test question or a quiz question, which you're going to have tomorrow, if you're told the center on an ellipse is 2, -1, you ought to be able to write something down. Samantha, what can I write down?
X plus 2.
Careful.
No, minus 2.
X minus 2, quantity squared. What's that? And then Y plus 1, quantity squared. Put lines, say that equals something. It equals 1, right? The only thing we need to do now is figure out what goes underneath the X and what goes underneath the Y. So let's draw a quick little sketch. 2, -1, label that as the center. Focus is at 3, -1, so focus is at 3, -1. There's a focus. And a vertex is at 5, -1. So here's 1, 2, 3, 4, 5. Right there is a vertex. Now, if I wanted to, I could fill in the other stuff. If there's a focus, everybody watching? If there's a focus on this side of the center, there's got to be a focus over here. If there's a vertex on this side of the center 3 units away, I've got to have a vertex over here 3 units away. So, how far is it from here to here, and how far is it from here to here? How far is it from the center over to the vertex? 3. So we'd square that. That's 9. What does that go underneath? It goes underneath the X because we went in the X direction. So that's going to be a 9. So the only thing we have left to find is what goes underneath this. And remember, it's the big one minus the small one equals C squared. So that's going to be 9 minus B squared equals, what's C in this case? 1. And then just solve for that. So that's going to be 9 minus 1 equals B squared. That means 8 equals B squared. You don't have to find that it's 2 radical 2 for B or 2 radical 2 is what B is. What we want to know is what's B squared, what goes underneath the Y, and it's an 8. There's our answer. Any questions? Okay. Last couple and I'm done. You can have the rest of the time to work. Take a good look at this one and this one. Okay, we already graphed this. What shape is this? Got to be an ellipse. Center at 1, -1. And we go 5 units in the X direction, so about here. And 3 units in the Y direction, about here. Draw something that looks about like that, or better. What's this? It is a circle. Everybody watch, please. Okay, I need you to just watch. Eyes up here. Okay, this is a nice graph-friendly form of an ellipse. Okay, we have a perfect square with x, perfect square with y, and a 1 over here. And we look at these numbers underneath to tell how far we go in each of these directions. So we look at the number underneath the x to figure out how far we go in the x direction, number underneath the y, how far we go in the y direction. Of course, we take the square root of each one of those, right? What if I did this way? And wrote this as x minus 1 quantity squared over 25 plus y plus 1 quantity squared over 25 equals 1. What if I treated that like I did an ellipse? So what's the center? 1, negative 1. How far would I go in the x? 5. So I'd go 5 over here, I'd go 5 over here. How far would I go in the y? 5. So I'd go up 5, I'd go down 5, and it would look like this. So the only difference between a circle and an ellipse, you could really treat a circle like you do an ellipse. Okay, if you wanted to group them together and say, you know what, keeping track of 4 conic sections, that's a pain in the butt. Okay, but a circle and ellipse are basically the same thing. It's just that if there are different coefficients in front there, we go a different amount in each one of those directions. So the coefficient here is 1/25th. The coefficient here is 1/25th. We go 5 units in each of the directions, x and y. Okay, on this one, the coefficient is 1/25th. We go 5 units in the x direction, but only 9 in the y direction. Is that good with everybody? Okay, think about this. 1/9. It's kind of like a shrink in the y direction. Okay, 1/25th. It's a shrink, but not quite as much, if you wanted to think of it that way. Okay, the 1/9 is smaller than the number is smaller. Okay, that 9 smaller, so we go less in the y direction than we do in the x. Yeah.
So explain the difference between a square and a rectangle, because a square is technically a rectangle.
Yeah, a circle is a special type of ellipse. You could think of it that way. By the way, on this one, what's the big one minus the little one?
0.
It's 0. Where are the foci? They're right at the center. Very good. They're right at the center. We didn't go anywhere. We didn't move the foci anywhere. Okay, so it's like taking that string and putting both of those foci right at the center and just going around and making one circle. Okay? All right. Let's take a quick look at a few problems from the assignment like we did for the ones on parabolas. So we're on, this is page 751. And I just want to point this out and get you started on a few of them. So 21, 25, 44, and 57. So take a look at number 21. Okay, again, this is typically where people struggle. Information about an ellipse, come up with the equation. Okay? So let's sketch this really quickly. Foci at 0 plus or minus 3. 1, 2, 3. 1, 2, 3. Please don't mess up the x and the y axis. Here's a focus, and there's a focus. Automatically, what do you know about the equation of the ellipse? Where does the big number go? Underneath which variable, x or y? It's going to go underneath the y, right? Because the foci run on a vertical axis in the y direction, so it's got to have the bigger number underneath the y, because they're on the major axis there. Okay? X-intercepts are plus and minus 2, so that means it crosses right here. Okay? So we could call those vertices if you want. Okay, sometimes it'll only say the vertices are at the endpoints of the major axis, but that's fine. If you want to think of it that way, that's okay. These are points on the ellipse. Well, wait a minute. Where's the center? 0, 0. X squared over something plus y squared over something equals 1. Do we know either of these numbers? From the center up to a focus, that's not one of those numbers. That's C. From the center over here, how far did I go in the x direction from the center? 2. What number goes underneath the x? 4. Put a 4 there. And again, we're expecting a big number underneath here. So it's a squared minus b squared equals c squared. Do we know any of these? Do we know the big one? Do we know the small one? Do we know c? Okay, we know the small one. That's a 4. We know c. C is 3, so this would be 9. So a squared would equal, or a squared minus 4 would equal 9. So a squared is 13. Do we need to do anything with that? Nothing other than put it right there. That's it. That's all there is to it. Again, hardly any math, just a bunch of thinking. Look at problem number 25. Good to move on? Okay, 25 looks like this. It has a center at 0, 0, and then it does, let's see, about like this. Not so potato-y though.
You said I had a center of 0, 0.
Oh, did I? Sorry.
Yeah.
Negative 1, 1. There's the center. Just looking at that, if this were a test question, what should you be able to do? If you know the center, what are those variables?
Oh, you know H.
You know H and K. Go ahead and write down. How are we doing there, Max? Good? This is going to be x plus 1 quantity squared over something. Y minus 1 quantity squared over something equals 1. And then it's just a question of figuring out, well, gosh, what number do I put underneath each one? So let's look at this. From the center, how far do I go in the x direction? This way and that way. 2. So what number do I put underneath the x? Square that. That's 4. How far did we go in the y direction? 1. Okay, it's just 1. This is 0. This is 1. This is 2. Sorry about my scale. Okay, so I go 1 unit. So what number goes underneath the y? Just a 1. Square it. Okay, don't add them together. Square it. Okay, it's not how long is the whole thing. It's how far is it from here to here, and then you square that. This is 2. 2 squared is 4. Okay. From here to here is 1, so 1 squared is 1. That's why that goes there. Any questions? Okay, let's see, what were the other two? 44 and 57. So we'll flip the page over. Here's 44. Again, a lot of these are descriptions. It says foci at 1, 2 and negative 3, 2. And a vertex at negative 4, 2. Okay, and again, when they say vertex on major axis. Okay, so when they talk about a vertex, they are saying those are the ends of the major axis. So we'll sketch what this looks like and we'll label the points. 1, 2, there's a focus. Negative 3, 2, so 1, 2, 3, 1, 2, there's a focus. And then it's got vertices at negative 4, 2, so 1, 2, 3, 4, there's a vertex. Now let's think about this. If there's a focus on either side here, and there's a vertex over here, 1 past the focus, wouldn't there have to be another vertex over here? And if this is 1 and this is negative 3, wouldn't there have to be a center right in between there? Because all of these are located on the major axis. So right here. Let's see, if these are all 2 units above, so like that point right there, that would, well, let's see, let's label this one -4, 2. All of these have the same y coordinate of 2. So this point, the center would be where? -1, 2. Okay, what can you fill in from that? H and K. X plus 1 quantity squared over something. Y minus 2 quantity squared over something equals 1. You can fill in, once you've got the center, you can fill in all of the equation except for A and B. And we can even figure these out now. How far is it from here to there? From here to here. Not funny. 1, 2, 3, right? So since that's 3, we square that number, we get 9, put it under the x. And then we do the big one minus the small one to get c squared. I know the big one's 9. I don't know the small one, but I do know that c is 2, so this would be a 4. So what's b squared got to be? We already did this problem right here, right? It's 5. So this is going to be b squared is 5. Okay, there's our answer right there. Okay? Any questions? Okay, and the last one is an application one. It's problem number 57. Again, these tend to be kind of tough because you've got to read it and interpret a lot. Number 57. Okay, Whispering Gallery. Has anybody here been to Washington, D.C.? Okay, did you go to the Capitol? Okay, did you? Okay, in the Capitol building, there's a rotunda where they've got 2 spots. So the room is shaped something like this, and there's a spot right here and a spot right here. It's a gigantic room. I mean, it's probably 100, 150 feet across. Yeah. They do. I haven't been there. It's pretty cool. You want to tell us about it? What happens?
Me and my friend were standing on the opposite side, and if you whisper, you can hear each other.
Okay, so Ira can be here and her friend can be here, and they can whisper. You can be a long ways apart. At the Capitol, you're probably 80 feet apart or so. There are tons of people in this rotunda and everything. Everybody's talking, and you can stand here and whisper, and the person over here can hear it. Okay? In fact, anybody in this little area here can hear anybody in this little area right here. Okay? Yeah.
It was weird though, because when you stood right in the center, if you whispered, you could hear yourself like very loud.
Oh, really? Kind of echoed back? Okay. Anybody know why that is? Math, yes. That's a focus, and that's a focus. So anything, any sound that bounces off here, like there's some sound that goes straight there, but some of it would go over here and it gets bounced right there. Some of it would go here and it gets bounced right here. Some of it would go here and it gets bounced right there. And vice versa. Anybody talking over here, it bounces off, and those are the 2 concentration points there. Okay? So it's really interesting. If you ever get a chance to see one of these, have somebody talk right here, stick your head right around here, you can hear them really well, and then move just a little bit. In fact, what's really weird and counterintuitive is if you're here, you can hear them really well, and you'd think if you walk closer to them, you can hear them better. You can't. Once you get far enough away from this focus, you can hear them worse. Okay? And you can get really, really close before you hear them any better than what you heard them that far away. So it's kind of cool if you ever get to see one of those. Where's that park in Draper? I've heard of that.
I can't remember, but it's just a big, huge open grass field, and you just see this.
There you go. Okay, wander around Draper for a couple weeks, you'll find it.
It's right up on
Oh, really? Cool. Nice. Okay, so this says this hall is 100 feet in length and is to be designed as a whisper gallery. The foci are located 25 feet from the center. How high will the ceiling be at the center? So here's what we're doing. Okay, we're designing the ceiling so that everything will bounce off and hit at those 2 points. It's going to be 100 feet long altogether. So how far do I go in this direction? 50 feet over here. So this would be 50 comma 0. And this would be negative 50 comma 0. Okay, I've kind of just naturally set this up. So this is the y-axis and this is the x-axis. And then it says the foci are located 25 feet from the center. So I've got a focus here and a focus here. That's 25 and that's 25. And it says, how high will this need to be? Let's ignore that question. Let's say I gave this information to you and I just said, come up with the equation. Where's the center? Tells you this. What goes underneath here? What goes underneath the x squared? 50 squared, so that's going to be 2,500. How do we figure out what goes underneath the y? Big one minus small one equals c squared. The big one is 2,500. How much is c? 25. So that's going to be 25 squared. So that's 2,500 minus b squared equals 625. So b squared equals, this is going to be 1775? No, 1875. Is that right? Did I do my math right? Seriously, Charles? You checked me? Pretty sure it's 1875. Is that the answer to the problem? Okay, the answer to the problem is, how long is the semi-minor axis? Given this information, how long is the semi-minor axis? Not half of it. Square root of that. If b squared is 1875, take the square root. This whole problem was basically just saying, hey, what's b here? So square root of 1875 is? Charles, it's your job. Square root of 1875. We'll get that answer. Okay, that's 43.3. Thank you. 43.3 feet. So it's going to be 50 feet in each direction and then 43.3 feet tall. Okay? All right. Okay, go ahead and get busy on the assignment. Remember, tomorrow you're going to have a quiz on parabolas and ellipses, so make sure you've practiced enough.